All right, so here's how that looks. And that's g of x. Okay, had I graphed cosine of x, like plain old cosine of x, it would have started at 1 and ended at 2 pi. It would have looked like this. That would have been f of x equals cosine of x. So you see how much quicker that would have started and finished, but now cosine half x, it has a longer period, so it's much, much, much slower. All right? What is the difference here? The difference between these two waves, this could be the difference between like a radio wave, like an FM wave, which is completely harmless, and a much faster X-ray, which is not so harmless, okay? Or a gamma ray that could actually kill you, okay? All right, so let's talk about frequency then. Like I mentioned, I can have a radio wave that could look like that, okay? A very, very slow wave. I could have an X-ray that looks like this. That concept that it's a much faster wave, that has a lot more energy associated with it, and so it could be a lot more harmful to your body. The difference, the only difference is, look at this. This has a much longer period, and this has a much shorter period, okay? The difference also is their frequencies. So what's a frequency? The frequency is the reciprocal of the period. Basically, it's 1 over the period, meaning b over 2 pi. So whereas the period is how long it takes for the wave to complete, the frequency is if you are looking at the waves, right, and you time them, how many peaks pass through you in a second, that's what the frequency is. All right? So in this example here, remember how we had said the period is 2 pi over 5? The frequency would just be 5 over 2 pi. Right? Just the reciprocal, that's all. All right, let's go over this example. So look at this. A bass tuba can hit a note with a frequency of 50 cycles per second. That's a very low frequency. That's like a low note, right? And an amplitude of 0.75. So I have frequency is 50 and amplitude is 0.75. We want to write an equation for a cosine function. Okay, well, what does an equation for a cosine function look like? A cosine bx plus c plus d. Okay, so I need A and I need B. Okay, I'm given that frequency is 50. Well, what did we say frequency was? It's B over 2 pi. So I say, okay, that means B over 2 pi is 50. Now, when I multiply by 2 pi, B is 100 pi. So that's my B. I'm also given amplitude. Question, Yarden?
Yeah, I'm kind of confused with, so the frequency is 50, and we said that B is the reciprocal of the frequency?
No, we said the frequency was the reciprocal of the period. So remember how we said the period was 2 pi over B before? The frequency is B over 2 pi. Okay? So I have B and I have A, The problem gives me no other information having to do with C or D. This is all I'm given. This is all I work with. Huh?
What's the A?
A was the amplitude of 0.75 right here. So I just plug in what I have, 0.75 cosine 100 pi x, and that is it for the equation.
How can that be the equation if we are just skipping out on two numbers?
Well, those other two numbers have to do with a phase shift, like a horizontal shift and a vertical shift. And if this function doesn't happen to have those, then it doesn't happen. Then it doesn't have them.
So that means that it's just an origin, basically.
Exactly. Yeah, the C and the D are just placeholders in case you have those like features. Okay, so let's talk about phase shift. Phase shift is the horizontal shift. So whereas in algebra we used to call it a horizontal shift or a horizontal translation, in trigonometry, trig has its own set of vocabulary. We call it a phase shift, right? The way I want you guys to solve for the phase shift is I want you to solve that term bx plus c equal to 0. So set that equal to 0 and then we solve it, right? So bx plus c equal to 0. Well, if we just do it with the symbols here, I have that bx is equal to negative c, and then I divide by b, so x is negative c over b. So in a lot of books, you know, they have that as like a little formula, but it gets to be so many things to remember. All I want you to remember is 2 pi over b for the period, and then for the phase shift, I just want you to solve that equation, and that's it. Okay? All right. Look at this remarkable and beautiful function right there, right? I mean, there's just such beauty in that function. So we're gonna graph that function right now. Okay, like it just brings me joy just looking at it. I could see that on a billboard, like walking down the street, just that function, and it'll just make my day. So let's graph that guy. But before we graph it, we gotta put in some of the features here. Okay, amplitude. Can somebody yell out what the amplitude is? 2. And the period, 2 pi over what? What's b here? Pi. So it's just 2, and that's okay. The frequency, no math involved, just the reciprocal of the period. You're not going to do any thinking for that one. If you're overthinking it, you're doing it wrong. Those are for free points, that frequency. Phase shift.
Why is the frequency half? I'm a little bit confused.
Because it's the reciprocal of the period, always. Whatever the period is.
But not the negative reciprocal?
Huh?
But not the negative reciprocal.
No, that's negative slope. That's perpendicular slope. Okay, phase shift, I take the stuff after the sign. That's like the argument of the sign. Set it equal to 0. I subtract pi over 4 from both sides. So I have pi x equals negative pi over 4. Now I'm going to divide by pi. Dividing by pi is like multiplying 1 over pi. So x is negative 1 over 4. This tells me the graph has shifted left by 1 over 4 units. Okay, so this has it's period modified, it's shifted, there's all sorts of stuff happening here. So what I do is I take the same thing that I used for phase shift, that same term, and I bound it in here from 0 to 2 pi. So let's solve for x. Remember back in the day in algebra when you used to do this and you thought it was so pointless? But look, here's another application. Negative pi over 4, pi x, and then this one is 2 pi minus pi over 4, 7 pi over 4. I'm going to divide by pi. That's like multiplying by 1 over pi. And I'm going to get negative 1 over 4, x, and 7 over 4. What that is the beginning and ending of the cycle. So this is the starting point. I put it right there. And then I go 1, 2, 3, 4, and I put the ending point, 7 over 4. Now we got to find the points in between. I just start like splitting regions in half. So I'm going to color code this. First, we're going to find the very middle in red. And that's the midpoint of the first two, right? How do we find midpoint? Add and divide by 2. So look on my screen. Here's how I think of it. That red point is halfway between negative 1 over 4 and 7 over 4. That's by far the easiest way I've found to think about what this midpoint is. So this is half of 6 over 4, and that's 3 over 4. Hey, look, if you can do this in your head, I don't need to see the work for this, right? This is like, you know, just simple math stuff. I mean, not simple, but like, it's not the pre-calculus of it. So if you can do it in your head, do it in your head. I don't mind. I know you guys are all, you know, savvy with this stuff. Okay. This one, that blue, is halfway between negative 1 over 4 plus 3 over 4. Half of 2 over 4. That's a quarter. And then finally the green is halfway from 3 over 4 to 7 over 4. Half of 10 over 4, 5 over 4. Okay, that took so long, I don't even know if we were graphing sine or cosine. Oh, look, it happens to be a sine. That means, where do I start? On the axis or on the maximum?
Axis.
On the axis. All right, I start here. Okay, and then I'm just gonna go like boom, 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 boom. I go up to 2, because that's the amplitude. 0, down to 2, 0. There. That's like the epitome of beauty.
So the period changing, what does that do to the graph?
The period changing either scrunches it down so it's a lot faster, or it elongates it. It makes it slower. So the period here is 2. Normally the period, the default of a period is 2 pi. 2 pi is 6.28, right? But this thing started and finished over a period of 2. Hey, where would the y-axis go here? Where would x equals 0 be?
Between negative a quarter and a quarter.
Yup, right there. Okay? And you see how I put that later? Okay? That's cool. Like, draw your graph first and then do it. Okay. The next one, What is new here is that there is a +1 at the very end. That is a vertical shift. That moves the graph up by 1. So let's do this pretty quickly. The amplitude here is 1/2. The period is 2 pi over 1. The frequency is the reciprocal of that. The phase shift, I take this, set it equal to 0. So x is negative pi. Okay. To graph, I'm going to go from 0 to 2 pi, and I'm going to put in here x plus pi minus pi, minus pi, minus pi. This is a more straightforward one with the numbers. So this goes from negative pi to pi. All right. This one, I'm going to start here, and you know what? I'm not going to skip spaces just to show you that it's okay. The midpoint of those two is 0. And then here I have negative pi over 2 and pi over 2. Okay. Check out what the difference here is. Until now, all of our graphs had been oscillating around the x-axis. That was the axis of oscillation. Now, there is a vertical shift of 1. That means the axis of oscillation moves up 1. So I go to here, 1. That is going to be my y equals 1. And I put in my new axis of oscillation. Now, sine starts on the axis of oscillation, so it's going to start on the axis right there, and then it goes to maximum, 0, minimum. The maximum here is not 1 but 1/2, because the amplitude is 1/2. 0, minus 1/2, 0. And look at that. Is that just the cutest little thing you've seen in your life or what? Right? And the y-axis would go here. Okay? So in trig, the y-axis is almost like the secondary axis. It's all about the x-axis. You know how in Britain everything's about the queen, and that poor husband of hers is just lags behind, right? Have you noticed she always walks first and he always walks like a step behind her? That's sort of the situation here. It's all about the x-axis, and then the y-axis is like a step behind, right? It's all about the x-axis.
Will you explain again why you have the y equals 1?
Yes, because here I had this term +1. That is a vertical shift. So it moves everything up 1. So just like, all the points will move up 1, so will that axis that it's rotating around. Okay? All right. So with that, oh my God, it's 10:22. I gotta let you guys go to bonus. Okay, so there is homework associated with this. Look, I didn't get to all of it. So on the homework, do it tonight when it's fresh in your mind. But just do the ones that ask you to graph. Skip the ones that ask you to write an equation, and then we can take care of it next time. Okay? I'll put this screencast online, and I'll send you the notes, Tal. Okay?
Thanks.
All right, guys. Have a fabulous time in bonus.
Thank you.
Bye. Hey.
I have a quick question.
Yeah.
Like when we do an equation, how do we know to put f of x or y equals?
It's the same. Just put something. Don't ever leave it blank. Y or f of x, they're synonymous. Just put one of those.
Thank you.
Mm-hmm. Hey, Eli.
Hi. 2 questions.
Mm-hmm.
Did you say I turned in my homework 3 on equatio? I just want to make sure it's
yeah, let me see.